learning, today would be a good day to start off with a warm-up. So take a look at these problems. Sine x divided by tan x times the cosine of x, and 3 tan x sine x. So take a good look at these problems. I would suggest pausing the video, trying them, and then unpause and let me go over it. You might recall when we first went on, remote learning, March 16th, we were finishing up some of these identities. So I see division here, so let's rewrite it. Sine x divide tan x. Now last I knew, the tangent is equal to sine x over cosine. Now remember, that's given to us on our reference page. But what do you do when you divide fractions? We stay, change, flip, right? So sine x, this becomes times, and we flip. So the cosine x takes the numerator spot and the sine x is in the denominator. So now you probably have an idea what's going to happen next, correct? Who's going to cancel? Sine x, of course. So our final answer is just cosine of x. Example number 2. Tan x times cosine, again, right away, let's ditch that tan x. Sine x over cosine x replaces tangent, times cosine of x, and what cancels? Cosine x here and here, and your final answer is just sine x. Last example, oh boy. Well, let's rewrite this. Remember how I used to say in class, I am vertically challenged, so let's rewrite it horizontally. So 2 tan x divide by sine x. So then we replace the tangent, so it'll be 2 sine x all over cosine. So notice the 2 and the sine have to partner up together. This becomes times, and then we flip the sign, so it'll be 1 over sine. Now what happens here? Only the sine x cancels. So the only value up in the numerator when you multiply across is 2, and the denominator is just cosine x. Now you're probably wondering, we haven't done a bell work. So what's the point of that? Well, in today's lesson, when it comes time to solving trig equations, we're going to see sine and cosine together, and that's a no-no. Because when we solve trig equations, we want to make sure we have only one variable. So it's not a GCF question like yesterday. I mean, it's okay with the sine double angle to have a GCF. We factor out sine or cosine. But this is a situation. So what we're going to try to do is to reunite these two terms and make it one. You got it. We're going to try to make these terms into tangent. So once again, when it comes time to solving these equations, read the directions. So today we're going to solve for x. Wonderful. We're going to be in degrees. 0 less than or equal to x. Why, look at that. Less than or equal to 360. So if we do get 360 as an answer, we do include it this time. Now let's check out the rounding. If necessary, round to the near, oh, nice, no decimals, yay. So what I would do is separate the two terms out, okay? So sine x can stay, that's fine, equals, bring the 2 over to the opposite side as negative 2 cosine of x. Now we want to change so we have one trig function. I know that tangent is sine over cosine, so guess who gets the boot? You got it. Cosine. We're going to divide both sides by cosine of x. This becomes now tan x equals, the cosines cancel, guess what it equals? Negative 2. This is something I would be really shocked if you've seen it before. So again, the idea is both sine and cosine are both degree 1 terms, but they cannot coexist together like this. So we're going to have to do, they have to join forces and become tan, okay? So what happens here now with tangent, I need my calculator, so I happen to grab my graphing calculator today. Double check the mode, make sure, okay, wonderful, my mode still is in degrees. So remember, we're going to work backwards. We're going to try to find the angle whose tangent is equal to negative 2. Great review because, whoa. Negative 63 degrees. So again, remember the analogy I used the other day? It's like me throwing darts. I'm missing the target. So what do I do with an angle of negative 63 degrees? I mean, I can't keep that as an answer. No, this is great review as we prepare for we'll see, future ACTs or SAT takers out there. Draw a picture. Think back to your days of geometry. We are going to draw an angle here in quadrant number 4. Voila, here is negative 63 degrees. So remember the Jerry Maguire movie. Not sure if anyone watched that while we're on break. Lots of movies on TV to get caught up on. But in any case, the angle that completes can be found by simply taking 360 and subtracting 63. So you're going around the other way. There you have it. 297 degrees is our first answer. It's not our only answer because we remember that tangent is negative in one more quadrant. You got it, quadrant number 2. So what you do is draw a quadrant 2 angle. Doesn't have to be pretty. Label the reference angle 63, and this answer right here is what we're looking for. Again, use your geometry, take 180 and subtract 63, and you should get that angle, which is 117 degrees. So again, the key here is we can't have sine and cosine cohabitating together. We have to divide. And we have to divide by cosine because, remember, tangent is equivalent to sine over cosine. We can't change that. So, you know, if you have a brother or if you have a sister and you guys have to share a bedroom with bunk beds, it pretty much is decided who gets the top, who gets the bottom bunk. You don't get to switch every night. One's the top, one's the bottom, and then you're done. Okie dokie. Example number 2. Another scenario here. Okay, who's going to get the boot? Cosine. Sayonara. So you're going to divide both sides by cosine. So we have square root of 3. Together, sine over cosine gets the switch, becomes tangent of x. Cosine, now this is interesting because when people divide both sides by cosine, I forgot to mention example number 1, cosine divided by self is 1, okay? Don't laugh. I can hear you from as far away as where I live. I've seen people on quiz and tests, when they cancel, they put a 0 there, so be careful. So cosine divided by self is 1. Now divide both sides by the square root of 3. Gosh, I don't know why these numbers look familiar to me. Like tan of x is equal to 1 over the square root of 3. Okay, let's go to the calculator. So we're working backwards. Second tans, remember the negative 1 exponent is tan inverse. We want to enter that fraction. 1 divided by square root of 3 works just as well. Calculator understands what's happening here. Get in the habit, closing. Ah, that's right. That's the 30, 60, 90 triangle. Oh, I feel like a dunce, but I knew it. I just was playing along. You don't remember your 30, 60, 90 triangle. It is not the end of the world. Okay, so use the calculator. So it turns out we get one answer, 30 degrees, but there is one more quadrant. Tangent is positive in. Not 4, not 2. You got it, quadrant 3. So when you're trying to find the quadrant 3 angle, you just add 30 degrees to 180, and voila, 210. Last example here. So we're going to divide both sides by cosine of x. Cosine of x. So we get here the tangent of x is equal to 5. That doesn't look familiar to me. Now, I know some of us had some questions about day 1's homework because when you go to the calculator, I know this isn't the problem, but let's talk about it. Sine. If you go to the calculator and try to find the angle whose sine is 5, you're going to get this message here. Okay, remember, when we graph the sine cosine curve, the maximum value for sine and cosine is 1. Likewise, the minimum value for sine and cosine is -1. But don't be alarmed. When you work with tangent, the range of tangent graph is all real numbers, right? So you'll get an answer here. We're going to round. Let's round to 79 degrees. So 79 degrees is your answer here. And let's see. Tangent is positive in quadrant number 1 and 3. So if we add 79 to 180, we'll get the quadrant 3 angle, which is 259 degrees. Hopefully this makes a little more sense now that you see me doing it. Maybe at first when you looked at it, you thought, whoa, there's no GCF. And you're right. There's no factoring, no GCF. So what you're going to have to do is you pretty much have to make some cosmetic changes to your equation. So you want to divide both sides by cosine, getting sine in the numerator, cosine the bottom. If you flip-flop it, you're going to get a reciprocal function. And remember, we do not study reciprocal functions in IB math. So probably what will be nice now for you to try, homework is day 3, I believe, on the list, but there is an exit ticket for this. I will upload it on a different video and go over in case you need some more practice with it. Good luck, and again, if you have any questions, just shoot me a message or email me. Have a great day. Bye.